So it is important to understand inverse functions as we study log functions, because log functions are inverses of exponential functions. What is a function? Big idea of algebra. Each x has only one y value. That is the definition of a function. Each x can only have one y value, right? And x has to map to one output. You can't confuse your x's. 7 needs to go that it goes to 10. 7 can't go to 10 and 30 at the same time. It'll break up the line. The vertical line test. So if a vertical line only touches the graph once, it's a function. So the vertical line can only touch the graph once. It has to pass the vertical line test. Guess what? A parabola passes the vertical line test. Anywhere that I want to draw a vertical line, I can only touch the graph once. A shape that would fail the vertical line test is a circle. That's not a function. If I draw a vertical line, I just hit the circle twice with the same vertical line. So that's a quick way of deciding if you have a function or not. We need to know what a function is in order to understand inverse functions. So an inverse function is found by just exchanging input and output values. X and Y, right? A comma B becomes B comma A. That's all you have to know. Switch X and Y. That's all an inverse is. Inverse notation is written F to the negative first. I hate that they use this. We just learned that that's a reciprocal, right? That notation means inverse, not reciprocal. So I don't know why they use the -1 symbol, but just to confuse you, it just means inverse. Guess what? Domain and range are going to flip-flop. X and Y flip-flop, so domain and range flip-flop. A one-to-one function. Each Y only has one X. So basically, for it to be one-to-one, each X has one Y and each Y has one X. And the horizontal line test, it tests for a one-to-one function. So I'll say one-to-one functions. I'm going to say pass the horizontal line test because it's the same thing as the vertical line test. If you draw a horizontal line, you can only touch it once. So a linear function, that passes the vertical and the horizontal line test. What about the parabola? That's a function, but guess what? It fails the horizontal line test. So it says this is a function, but it's not one-to-one, so its inverse will not be a function. The inverse of a parabola is a sideways parabola, and it will fail the vertical line test. So its inverse will not be a function. If you move on to calculus, this is really important. For us, it's not so important this year. We're just trying to find an inverse. So all of these are like nice to know if we had like weeks to study inverses. I at least wanted to drop some words, in your vocabulary in case you study further. But I really want to get into how to find an inverse. Are we good on that page? All right. I'm going to skip this part about composition because I skipped 3. All right. Here's what I want to do. I want to find an inverse graphically and algebraically because that's what I need to be able to do for exponents and logs. So we're going to graph the line 2x plus 5. So that should be easy, right? A linear function. Let's graph a linear function and its inverse. So 2x plus 5, I start at 5. 1, 2, 3, 4, 5, put a dot. 2x, I go up 2 over 1. up 2 over 1. Have a good Easter and weekend. Down 2 over 1, down 2 over 1. There's my line. So that's the function y equals 2x plus 5. You with me? All I did was graph it. This says if a comma b is a point on the original graph, b comma a is a point on its inverse. I can take all these points, flip-flop them, and I'll have my inverse. So what is this coordinate? This is the coordinate 2, 9, right? So let me just write them down. 2, 9. This was 1, 7. This was 0, 5. Let's do one more. -1, 3. Right? Those are those sets of points if I just recorded them. All right. 2, 9 becomes 9, 2. There's my inverse. 1, 7 becomes 7, 2, 3, 4, 5, 6, 7, 1. 0, 5 becomes 5, 0. 1, 2, 3, 4, 5. -1, 3 becomes 3, -1. I just graphed the inverse function of those 4 points. Those are inverses of each other. An inverse will undo the other function, basically. And it says, draw in the line y equals x to show that they're mirror images over the line y equals x. See how that's my mirror image? So we're going to learn how to find the equation of an inverse. Right now, we were just graphing it. So there's graphing inverses, and there's finding equations of inverses. Remember, our goal is to solve a problem like 2 to what power gives me the number 13? Right now, I have no way of solving that problem. So I'm trying to come up with a mathematical operation that will undo an exponential function. Just like 2x plus 1 equals 9, I know that subtraction will undo addition, right? And division will undo multiplication. And the square root will undo a square. I don't have any way to undo an exponential function. So I need to learn a little bit about inverses to get there. All right, try graphing example 1 on your own. Plot 3 points and then flip them and plot their inverse. We'll do graph 2 together. But see if you can graph a line and find the inverse. I'm just going to record what those points were. -1, 3, 0, -1, 1, -5. So 3, -1, -1, 0, and -5. 1, 2, 3, 4, 5, 1. Is that about what you got? Those x's are the flips of those coordinates. The way you check for yourself is you say, hey, when I draw in the line y equals x, do they look like mirror images over the line y equals x? If you notice, this had a slope of -4. What does this have a slope of? -1/4. It might be hard to tell the y-intercept. Down 1 over 4. I guess the y-intercept would be -1/4, right? So y equals -1/4 x minus 1/4. Linear function. So if you had to write the equation, you'd have to find the slope and the y-intercept yourself. We're going to learn a different strategy, how to find it algebraically, which is what we need to get to logs. So did anyone learn about inverses in Algebra 2? Sometimes it gets talked about in Algebra 2. I was just assuming that we didn't quite get there last year. You didn't learn anything? Oh, okay. So x cubed. What's 0 cubed? What's the parent function look like? What's 0 cubed? 0. What's 1 cubed? 1 times 1 times 1? What's 2 cubed? 2 times 2 times 2? What's negative 1 cubed? Negative 1 times negative 1 times negative 1. Negative 1. What's negative 2 cubed? Negative 2 times negative 2 times negative 2. Negative 8. That's the parent function for x cubed. So what you do is you're going to flip-flop those points. 2 comma 8 is going to become 8 comma 2. Guess what happens to 1, 1, 0, 0, and negative 1, negative 1? When you flip them, they're still in the same position. And then I'd be at negative 8, negative 2. So see how it's kind of the sideways S is the inverse? And it goes through those 3 points because those 3 points lie on the line y equals x. If you lie on the symmetrical line, you're going to stay put. Does anyone know what function this is? We talked about it briefly. What would undo a cube? Not a square root, but a cube root. So it's the cube root of x graph. So linear functions have inverses, cubic functions have inverses. Quadratics do if you limit their domain, so it's a square root function. But so we want to find them algebraically so we can find the inverse of an exponent. So let's find them algebraically. And when we get back, we'll introduce this part to you. So we'll just do 1 and 2 on the back and then maybe go for a little walk. All right, finding an inverse algebraically. Your steps are, first, you need y in the problem, because if you're going to switch x and y, you need to see where y is. So your first step is I just rewrite y equals, if it ever says f of x, just so I know that's y. Switch x and y. So x equals 2y minus 3 divided by 4. You don't switch anything else. I literally took x and took y and switched their position. That is your inverse. We found it. The only thing that we need to do is write it as a y equals equation so that it's actually graphable. How would I get y by itself? What would be the first thing I'd want to do to both sides? Strip things away using order of operations. Can I add 3? What do I want to do first? I can't add 3 because I'm dividing the whole thing by 4. What's the opposite of division? So I really want to multiply both sides of the equation by 4 to get rid of 4 in the denominator. 4x equals 2y minus 3. What's my next step? I'm trying to get y by itself, people. Add what? Add 3. 4x plus 3 equals 2y. What's my last step to get y by itself? Divide by 2. So you could write your answer 4x plus 3 over 2 if you want, but that's not really helpful for graphing. You could separate it out, y equals 2x plus 3 halves. So it's easier to write it this way for graphing purposes, but if you're afraid you're going to mess up, you could leave it in that format because you technically found y equals. All right, so your last step. See if you can find the inverse on 1 and 2 algebraically. So make them y equals, switch x and y, and see if you can get y by itself. So you want to undo the operation. first one. The second one might be a little bit harder. I lost my pen. Where's my pen? Oh, here. So x equals 3x, y plus 5 divided by 2. Did you guys go with the distributive property and distribute the 3? Yeah, did you multiply by 2 first? Okay, so we multiplied by 2 first to get 2x. So then you distributed and you had 3y plus 15 as your next step. That's a good next step. You don't have to distribute the 3. You could actually divide by 3 right away and have 2/3 x over here if you wanted to. But now I'd have to subtract 15, right? 2x minus 15 equals 3y. And then I would have to divide by 3. So my final answer should be 2/3 x minus 5. So see how at this step, if you were just divided by 3, you'd have 2/3 x and then just subtract 5. You'd get the same answer. So number 2 is a little bit more challenging. I'm going to switch x and y. How am I going to get rid of a cube root? I'm going to cube both sides of the equation. So a cube on both sides will get rid of that cube root. So I have x cubed equals now just y minus 1 is by itself. So my final answer, I'd have to add 1. So algebraically, finding an inverse is just switching x and y. And then you have to solve for y equals. So we're going to be able to solve exponential functions pretty soon. Right now, we're going to find the graph of the inverse, and then we're going to do the algebraic inverse. All right, so I'm paused. Take a look at graph 1 and 2 to find exponential graphs. So we're going to draw the exponential graph, flip x and y, and find the log graph. So you're going to be introduced to what a log graph looks like. You'll see it again in more depth. But what are the key points of 2 to the x? Let's make a table. So let's use -2, -1, 0, 1, and 2. Right, so what are my key points for the exponential function? We know anything to the 0 power is 1. We know 2 raised to the first power is 2, and 2 squared is 4. So that's the right side of the graph. 1, 2, 2, 4. And then when I go to the negative exponents, that's just 1/2 and 1/4, right? The fractions, because it's the reciprocal of what you'd get. So there's my exponential graph of 2 to the x. It's very similar to the exponential graph of 3 to the x, right? This one also has a point at 0, 1. Where's its next value? 1, what? What's 3 to the first power? 3. 1, 2, 3. What's 3 squared? So 2, 9. See how much steeper that graph is? 1/3, 1/9 is kind of hard to draw, but there's my 2 exponential graphs. This one is much steeper than this one. So we're going to take our points that we just had. I guess we could write the points down for this one too. So we had 1/9, 1/3, 1, 3, and 9. So I'll give you a minute so you can write down the key points for both graphs. So if you have the key points, then you can just flip-flop them. So instead of 2, 4, it's going to be 1, 2, 3, 4, 2. Instead of 1, 2, it's going to be 2, 1, 1, 0. 1/2 -1 and 1/4 -2. So here's my log graph that you've never seen before. It's going to be our log function graph. It's a mirror over the line y equals x. There's your exponential, there's your log. And we could do the same thing for the 3 to the x graph. 1, 0, 3, 1, 9, 2. 1/3, 1/9. So it's much steeper in this direction because the exponential graph was much steeper in that direction. Your asymptote has flipped. This had an asymptote at y equals 0. This now has an asymptote at x equals 0. This one had an asymptote at y equals 0. So this one now has an asymptote at x equals 0. We're going to talk more about the graphs another day, but just this goes along with inverses, taking the inverse, flipping the x and y values. Why don't you do that last one, the guided practice question? See if you can graph that line, because then Eric can write these down on his paper. So see if you can do that, graph the line. It's a line this time. So just go to -2, slope of -4, graph the inverse, and find the equation algebraically. So that's kind of your check for understanding on inverse functions. Can you graph it, and can you find the inverse algebraically? It's broken? Really? I was having you, Eric, copy down. We did graphs 1 and 2. They're doing the guided practice at the bottom just to wrap up inverses. This is the same notes that we just left off on. I'm just going to slide it down to put up the answer to this last one, and then we're just going to introduce you to logs and do our Easter family feud. You should have started at -2, down 1, 2, 3, 4 over 1, right? Up 1, 2, 3, 4 over 1. Thank you. So if you had those key points as your line, this is -1, 2. So I'd have 2, -1. This is at -2, 0, -2, so -2, 0. And 1, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 1. That looks like that, right? Oh, it should have been a straight line. And then did you already find the equation algebraically or not yet? So then I want you to actually find what is that equation by switching x and y in the equation and solving for y equals. So finish it up. If you didn't try that algebraically, try it algebraically. Don't pack up yet because we're still going to talk about logs for a few minutes. Make sure we got them. We got Eric and Anna. Is that all they need for lunch? What do you want? I don't know what number this is. Oh, this is A for Eric. Was yours maybe a sandwich of some kind? Okay. So you want to, okay. I'll ask Carly. I don't know if they are doing it right now or not, but. He's still delivering lunches, so when you see him come back by, we'll grab him. Did Eric or Az, when you put your lunch ticket in today, did it give you a submission ticket, like your lunch has been received? So they haven't made that update in PowerSchool yet. Maybe next week. So x equals -4y minus 2. Add 2. And then I got -4y that I need to get rid of the -4. So I've got to finish by dividing by -4. So y -1/4 x, that looks right. That was that slope. And then the intercept must be at -1/2. So that must be -1/2 that I went through. It's kind of hard to see where you went through when it's not an integer. So being able to graph and find the inverse, I'll do some practice with that next week anyway. So if you could skip ahead to, so 313 we're skipping, 314 we're skipping, 315, we'll come back to those. I'd like you to take a look at the log function notes so that you're introduced to them with me, so that at least you've got a basis before going off in the world on your own. This is just an introduction to logs. I just want to show you that you can already do logs. If I just show you how to do one of these problems, it's like this whole new world opening. It's a mathematical operation you never knew, but you actually already know how to do because they're just exponent relationships. So find page 316. Does everyone have it? So log base 5 of 125, we're trying to evaluate what that is equal to. What it's asking you is 5 to what power is 125. It's just an exponential relationship. So the answer is 3. So if I said evaluate this log, the answer is 3, because how are 5 and 125 related? 5 cubed is 125. Let's do a couple together. So here, 2 to what power is 1/8? So what's the answer? -3, right? You're cubing it and you're flipping it over. All right, and then equals question mark. So 36 to the question mark equals 6. So this is another exponent rule that you were just tested on. How do I go from 36 down to 6 now? This was a negative exponent. See how you need all your exponent rules? How do I go from 36 down to 6? What am I doing to the 36? Taking its square root. So what power is that? 2 would be squaring it. How do I square root a number? Fractional exponent 1/2. All right, I'm going to skip down to example 6. It says when there's no base, use 10 as the base. So this actually has a base of 10. It's called the common log, just like a square root is a 2. A common log is a base of 10. So this is asking you 10 to what power is the number 100? So what would you say for 6? 2, because 10 squared is 100, right? They're all powers. Do you think you can try the rest of them and see if you can come up with what power? So this is the base. So 4 to what power is 64? 27 to what power is 9? 3 to what power is 3? So see if you can answer up through 18 with your exponent knowledge. So let's go through these problems. This would be 4 cubed, right? 4 cubed is 64. How did you go from 27 to 9? Remember, they both have a base of 3. So 1/3 would bring it down to 3, but then we need to square it. So it actually would be the 2/3 power, right? It's not just dividing by 3. You're taking the cube root and then you're squaring it to get 9. This is 3 to the first is 3, so 1. 5 squared is 25. 8 squared is 64. 2 to what power will get you back up to 16? 2 to the 4th. Yes, 2 times 2 times 2 times 2. How do I go from 11 to 1 over 11? -1, right? Flips it over but keeps it the same number. This one you might need a calculator for, right? It's 3 to the 4th power is 81. Did you figure this one out? How do I get from 2 to 128? You count them on your fingers. I think it's actually 7. 4, 8, 16, 32, 64, 128. So it's the 7th power, 2 to the 7th. 25 down to 5 is the 1/2 power, right? Square root. How do I go from 2 to 1/4? The -2nd power, square it and take the reciprocal. Anything to the what power is 1? 0. That's going to be one of the points on a log graph. And what about 18? -2. So we're going to have a very similar piece like that on Monday. It's 3:15. It's like a warm up, very similar to that to get you into logs.